Hi folks, we're going to take a look now at the Unit 5 Extra Review number 3. So here we're looking to write the equation of a function, but instead of given the graph, we're given a description. Okay, so let's see how that can work. So we'll start with B here. I'll skip A, that one's pretty straightforward. So quadratic function, so that means we're going to be transforming y equals x squared. So even before I go on, right off the bat, I'm going to write my general form for a quadratic or a transformed quadratic function. So a times x minus h squared plus k. So one reminder is notice there's no b value because we saw that it wasn't necessary for describing a quadratic function. And also notice that I'm using explicit notation here as opposed to function notation because I know I'm going to actually have to do some algebra with it. Okay, so now let's see what is up with this quadratic function. So it has a minimum point of 5, negative 4. Okay, so that tells me right off the bat that it's going to be opening up since it has a minimum point. And so I know even before I start that a should turn out to be positive. So if it does turn out to be negative, it means you've made a mistake. Okay, and then it passes through the point negative 1, 10. So let's just draw ourselves a little graph just to help us out. So negative 5, negative 4, or 5, negative 4. So there's our minimum point. And we know at some point it'll pass through negative 1, 10. Okay, so that's what our parabola looks like. Okay, so now let's identify what's important here. Okay, so we look at our minimum point. Okay, so if we compare it to y equals x squared, this is the point that would not have been affected by any stretches, so I can use it to determine my translation. So I see that that's been translated 5 to the right and 4 down. So let me start by including that information. So 5 to the right, meaning in my bracket I'll have x minus 5, and then 4 down. So here I'm going to be adding negative 4 or minus 4. Okay? So I've used the information given by my minimum point. Okay, so now in order to find the a value, I need to use the other information that's given. I've already incorporated this information into my equation. But the other thing they tell me is that it passes through the point negative 1, 10. So I can input x equals negative 1, y equals 10, and then the only thing I'll have left is my unknown a, so I can solve for it. So I'll input y equals 10. Okay, let's input x equals negative 1. Okay, and so here 10 plus 4, bring that to the other side, equals, so what do we have now? We have negative 1 minus 5, so negative 6 squared, so that's 36. A, and now I can solve for a, so 10 plus 4 is 14 over 36. But of course I would expect you to simplify that, so a is equal to, and they're both divisible by 2, so 7 over 18, and that's as simple as it gets. So now my final answer will be y equals 7 over 18. By the way, notice it's positive, as we expected. Okay, times x minus 5 squared minus 4. Okay, and there's our final answer. Okay, let's take a look at C here. So now we've got a square root function. So it has a starting point of 4, 3, and it passes through this point here, 0, negative 3. So again, I'm just going to draw myself a diagram to help me out. Because I do remember that with the square root function, keep in mind, remember we talked about not needing the b value. But we know that with the square root function, sometimes we do need to consider a b value. Okay, in particular, whether it's going to be 1 or negative 1. So let's just see what we get based on our graph. So here, 4, 3 is going to be our starting point. And then it has to pass through 0, negative 3. So that means my graph has to look something like this. Okay, but I notice that in order for it to have this shape, there has to be a reflection in the y-axis. Okay, now because I don't want to actually have to calculate that, when I write down my general form, okay, a times square root of, instead of x minus h, I know that I need a reflection in the x-axis. So I'm going to add in the negative on my own there, because I know it has to be there. Okay, so this is something that's unique to the square root function, that if you know there's been a reflection in the in the y-axis, you'll include that right off the bat in your equation. Okay, then everything else remains the same. So remember what y equals root x looks like. Okay, there's this point at 0, 0, which is unaffected by stretches, so that's what we're going to use to determine our translation. So we see that that point has been moved to the right by 4 and up by 3. Okay, so that means I can replace h by 4 since it's moved to the right by 4, so x minus 4, and then it's been moved up by 3 units, so k is equal to positive 3. Okay, and now again I can input the x and y value from our other point to solve for a. So here y equals negative 3. Okay, a, so here x would be equal to 0. Okay, and then plus 3. And so the only thing left is our a value. Now just to let you know, if you hadn't included that negative in the front, when you do 0 minus 4, you get negative 4, and you realize you can't take the square root of negative 4. Okay, so had you not done this, and you tried to solve the problem, you would have seen that you would have gotten an error on your calculator, so that would have been an indication that you had missed something. Okay, but now, so negative 3, then minus 3. Okay, what do we have left here? Well, we have negative 4, but the negative of that, so we have the square root of 4, which is just 2. Okay, so here we got negative 6 equals 2a, so a is equal to negative 6 over 2 is negative 3. Okay, and as we expected, there should also have been a reflection in the x-axis, and that comes out in the algebra. So our final answer is y equals negative 3 square root of negative x minus 4 and then plus 3. Okay, so just a recap to always start with the basic general form, but keep in mind that for square root functions only, okay, you may have to include a negative in the input if there was a reflection in the x-axis. Okay, sorry, in the y-axis. And so the best way to see that is to draw a diagram. Okay, that's it for these.